this is a study of a gaseous element, oxygen. Now, I strongly recommend that you review the other elements, or at least look at them for the first time, the two tapes on the solid element, copper, and the liquid element, bromine. Because we're going to start with this one the same way. We're going to start with the fact that we have to observe. And this is how chemistry starts. And let me just digress for a minute here, and we'll draw a little picture. Okay, that is called a glass, and you can guess what I'm putting in there. And I could say this is water in the glass, and I could ask you this question to observe this glass of water. I'm telling you the fact it is water. And I could say, is this glass half full or half empty? And you could say, when you're observing, you could say, what? Well, you're probably wrong, because the glass is completely full. It's about 50% full of water and 50% full of air. Air is called a homogeneous mixture. Homogeneous, that is not a swear word. Homogeneous means uniform throughout. Doesn't mean necessarily the same composition, but uniform in appearance throughout. That's what air is. But the mixture comes in because air is about 21% oxygen. Okay, so this is just to point out we're observing, and we have to use all of our senses and no value judgments. One of the first things that we note about air is it's odorless, colorless, and tasteless. It's clear. Now that can have impurities in it, and that can vary, but that's the first thing. Second thing we can say is that it's a gas at room temperature. It's a gas at room temperature. If you look at data, and I'll list a couple of data points. Let's list the melting point of oxygen. What do you think the melting point would be? Would you guess it's low? Try about minus 218 degrees Celsius. Water melts at 0 degrees Celsius, so that's a little colder. That's sweater weather, maybe even a heavy coat. If you heat up the solid, it melts. If you heat up the solid further, you have finally reached a boiling point. The boiling point is a balmy minus 183 degrees Celsius. So oxygen, essential for life, essential for life. Now let's look at the history a little bit. This is now going away from the observations. Oxygen discovery is around 1770. I don't have the exact date here, about 1770, a little later than that. And the reason I put that up there is because there is a real interesting controversy. If you look at the discovery, you can see the Swedish scientist Scheele. You can see the British scientists, and these guys were a long stretch on being a pure scientist that we know of now. And the guy that knew more than them in terms of the real world of oxygen was Lavoisier. Lavoisier really used their discovery, but some people like to give him credit. I would strongly recommend you watch the play on Lavoisier and Priestley and Scheele. It was written by a Nobel Prize winner and a colleague of his from Stanford. And these two guys, Raoul Hoffman from Cornell, and let's see if I can remember, I can't remember his name, DeGerassi, something like that, Stanford professor. But you can find that on the internet. The play discusses the 100th anniversary of the Nobel Prize, and it discusses who gets credit for something. They were thinking about sort of a retro Nobel Prize. Now, the last main thing I want to look at is density. We're going to put up a chart in a second here, but if you look at the density, I will tell you the density of bromine, and we already had this once. Bromine is 3.12 grams per cubic centimeter. Now you're going to see, if you look for oxygen's density, you're going to see the number 1.43. And I'm going to stop right there. 1.43. Now let's put up the chart. This chart comes from a tremendous website called About Chemistry, and you can learn everything about chemistry practically there is, and neat little facts like how to make a sorbet, to why apple seeds are poisonous and apples great for you, careers in chemistry, you name it. So I strongly recommend, I have the website address right below here, strongly recommend you go to that right after this so you have it in your mind for future reference. And I'll be using some of their charts occasionally. Now, let's go to the density chart. This is from the About Chemistry site. Okay, now, do you see the 1.43? Now, does that mean oxygen is basically half the density of bromine? Well, it isn't. If you look at the key over in the table, you see solids and liquids, which bromine is a liquid, is described at grams per cubic centimeter. That's the variable density. And gases are presented in grams per liter. You see that? Now let's go back to a calculation. We have 3.12 grams per cubic centimeter as bromine. But for oxygen, it is 1.43 grams per liter. Now 1 liter is equal to 1,000 cubic centimeters. So that'd be 1.43 grams per 1,000 cubic centimeters. Now I made that conversion because the reason they have that there, if we list it as grams per cubic centimeter, it'd be 0.00143. So for gases, you notice they wanted to have the numbers 1, 2, 3 with decimal places and be consistent that way. Otherwise, for gases, they'd have to drop down to 0.00. Okay? So the element oxygen, there's all sorts of things we'll be using oxygen with as time goes by. The next video you may want to look at is a greater exploration of the topic of density, and we will stop right there.